Well, good morning. Thank you for coming along to this. I hope you've had a good conference. I love 44Con. I spoke last year with my old boss here about sort of red teaming and what it means to try and get into the industry. And I released like a beta version of Sheepl 0.1 just as a kind of a taster to the types of things that I've been working on. I'm really into sort of mentoring and building training environments. I think it's really important that we have real-world representative environments to build skill sets in. And, you know, we're always talking about this big skills gap as to how do we train the people in the right way that are coming through the industry. And I've spent the last sort of 2 years, 3 years looking at how I can make my training environments more realistic. From a selfish point of view in the beginning, because I wanted to improve my own tradecraft, both from the red and the blue side. So a bit of background about myself. So I work for Spider Labs. I've done the Crest track, CC SAS. I spend most of my time looking at red teaming and pen testing. I've had quite a varied career in terms of the types of environments that I've worked in, which has been a good foundation for me. I'm a former Czech team leader, so I used to work for a Czech green light company and delivered a lot of that sort of work. I ran my own company for a long time, which was a really good experience. I think it gives you sort of an angle of business that you don't always kind of get if you're sort of employed by somebody. So I was out there selling. It was an IT consultancy service, and I was employing technicians. And that was kind of, I think, if I reflect back now in my mid-20s, that was really the start, the seed of all of this sort of stuff that I'm doing now. Because from my perspective, at the time, starting a limited company, I was the company, so people were buying me. And then as soon as I scaled it out to having technicians and things, all of a sudden they're no longer getting Matt turning up on site, they're getting somebody else. And I was like, well, that poses a really interesting challenge. How do I baseline people's skills? How do I train them? How do I mold them in the way that I want them to be? So I think the seed for that was already set. I've spoken a lot, but probably the most important part about this slide is I've been bouncing this picture around for a while, and a friend of mine says I look like a magician. So I thought I would just roll with it, and like, you know, I think it actually looks quite good. I might even start learning card tricks and stuff just to you know, bring it home. So the purpose of today, really, I've built a massive environment. I've been walking around in this suitcase with a big HP server. There's about 40 machines in there. They're clients. And what I really want to do is introduce to you why I think Sheepl is a really useful tool. I've actually used it in different ways, lab environments that deliver training for people. I've actually also used it on ops before to create noise. There's a big thing at the moment about distraction tactics and stuff. So there is some sort of real world. And I also did a pilot with some telcos where they were using it to evaluate some of their endpoint security software and whether it would trigger things like PowerShell download cradles, etc., and whether that logging would all bubble up. So give you an idea of how it all works, and then hopefully we can dive into some various different types of Sheepl. The idea being that it's kind of carte blanche for you. You can make good Sheepl or bad Sheepl, and it really depends on the types of things that you want to be focusing on. So a lot of the time I'll just create benign Sheepl that are going about mundane tasks, opening documents, opening command shells, even spawning processes as different users, so that I can practice tradecraft for understanding processes I'm in, and sort of moving around a network. And other times I'll want to look at it from the blue team perspective and how that logging comes up. So I'll have PowerShell version 5 and transcript logging enabled and event forwarding and stuff. And then I'll create Sheepl that are deliberately trying to do things like creating download cradles or trying to bypass AMPSI, all these sorts of things that attackers would do on a system. I wanted to see whether I could find ways of leaving that to log. So hopefully this should be an engaging and fun talk. I also want it to be interactive, because one of the things about this, at the point where we're saying, well, now you can type commands, I'm sure everybody has different ways of doing different things, and that's the feedback loop for me, is that you may do something completely different to I, and that's kind of what I want, because like, oh, that's an interesting way that we could emulate that person. So as I said, it all came from kind of a skills gap Initially, for me, I was looking at trying to improve my tradecraft. I still try and improve my tradecraft all the time, but I wanted to kind of look at ways that I could practice this sort of real world feel for it. But I kind of felt like I was just sort of flogging this dead horse, really, because I don't know whether you feel the same, but this industry very much, I'll flick it back to that slide because that can get quite distracting after a while, people just beating a horse. This industry is very much self-directed learning. I don't know whether you agree with that, but that's certainly been my experience of it. You know, you can access courses and stuff, but really the onus is on you to sort of develop your skills and explore these things. The problem with self-directed learning is, how do you know if you're looking in the right places, right? I mean, that's the thing. Like, if anybody's ever done OSCP or anything like that, where you hit challenges and they can sort of hold you back and really slow you down, that's great. I spent far too much money on my OSCP getting back into the labs again because I really wanted to know. So self-directed learning is really important, but then there has to become a point where it becomes an inefficient way of learning, in my opinion. You need that tenacity to smash into problems and, you know, keep on sort of going back to it over and over again and getting a good idea. But then at some point, you also need somebody to be like, it's not there, it's there. Or at least, why don't you go and look over there, not like, here's the answer. So I wanted to work out all that sort of stuff, and I was like, well, how can I do things like, let's say a user spawns a process and I'm trying to work with somebody to give them an insight into what it is to red team. What about, like, why have you injected into that process? Now it's all just crashed. Out of all of the process lists in here, which would be a good one to start? Did you see a process pop up and then disappear again? You know, all of these sorts of things I started focusing on, thinking, well, I actually need something to bounce off. I almost need like a sparring partner, essentially. Now, I'll say from the back, there's no AI in Sheepl, okay? There's no machine learning, there's none of this. You can get very creative with the way that they interact with the environment, but it really is you orchestrating how you want things to work. However, I've built a lot of entropy into this solution because I didn't want to be marking my own homework. That was my biggest frustration, is that script-based approaches, they're very predictable. You know, if a Python script will run every couple of minutes, it does exactly the same thing. And I felt that that kind of built a bit of complacency in me, because that's not how it happens in the real world. You know, if I know that something's going to happen every 10 minutes, then whatever. Am I really sort of building that sort of natural response in a way? So that was really important to me. And Sheepl, that's at the core of the project. The whole idea is that you don't know when things are going to happen. And I have plans to make that even more so. You'll see that there's some baking there. So there is some sort of predictability if you watched it for a couple of days, but I plan to make it so that that's completely random. But that was really important to me, so that, for example, if I'm keylogging and a Sheepl types an SSH connection credential into some server over a couple of days, if I'm not keylogging in the right process, I'm going to miss that credential. If I see that credential passed, I'm going to respond in the way that I would in the real world. And that's kind of the whole purpose of all of this. It's not me kind of going, I know when it's going to happen, so whatever. I want to be ready. I want to be focusing on developing my tradecraft. So as I said, you have to look at the ways that you're practicing, you know, this whole sort of practice makes perfect approach. Again, self-directed learning, as I said before, like, how do you know what you're actually practicing is the right thing to do? I never ceases to amaze me that actually it's how you ended up getting to that idea that that would be good to do. So we really want perfect practice makes perfect. If we're going to smash into things, let's really go for something hard and really test that theory. So that was quite important to me. How am I developing myself? What can I do? What tools are out there that are available for me? And how can I improve? So this is a wicked quote from Michael Jordan. It basically says that if you spend all day doing the wrong thing, you just become really good at doing the wrong thing. So I was like, oh, okay, yeah. How can I make this better? And it's because we have this sort of assumed breach. This is where we are with customers now. We're assuming breach. We're saying to people, well, you know, what's going to happen? Is somebody going to get in? Like, it's inevitable that somebody's going to get in some way, even if it's inside a threat. What does that look like? You know, can you even see it within the context of the network? Particularly have you have a massive network? These are real challenges for people. I'm sure if you've seen different size networks, you know, it's quite easy for us as attackers to come in and go, hey, I owned all the things, like blah, you know, and pointing fingers at the IT department. But I was a sysadmin for 10 years and I've seen some very big networks. And some of this stuff is really, really hard to secure. And even so, there's still a threat, the admins with the keys to the kingdom, right? So there's this whole sort of idea of, can you see things when they're happening? And do you even know what you want to be looking for? And if everything starts burning down, do you even know where those fires are? Let's say you've got 50 fires throughout your network, which is the most important fire to start with first. So the more I work on this, I kind of feel that I'm kind of turning into a red, blue type mishmash, purple, whatever, because I think that both sides inform the other side. How long does it take you to do that? You know, what is the delta between you detecting this and actually being able to respond? And that's where Sheepl are really cool, because you can create them over hours, minutes, hours, or days. There's a sleep function in Autoit that you'll see later on that I use heavily. And one sleep cycle, and you'll see I use it a lot, one sleep cycle can be up to 24 days. So it's realistic that you could create a Sheepl that basically did 1 or 2 tasks over a period of a good few weeks. I've had them running on a loop, one iteration of a loop, as you'll see, for a couple of days in the labs, basically because I haven't got too much time to wait for these things to happen. And the runtime itself is pretty solid. So I think these bring in interesting opportunities for how we can remove that stuff. A command happens, and then a couple of days later, another command happens, and we kind of go from that perspective. And I guess as incident responders or SOCs, you need to be able to draw the correlation between those threads. And if it happens in a very short sequence of time, then that's fairly easy to sort of isolate an event. But if it happens over a prolonged period of time, then that becomes quite a challenge. So as I said, I've got this project called LabSeed, which I've been working on for the last year, and my idea is to automate all of this now. So this is the kind of a representation of what we have here. We're kind of in this DMZ bit, so when you get an IP address, you'll essentially be in this range, and there's quite a few servers and stuff for you to work with. I use Vios, if you've ever heard of anybody heard of Vios before? Viata, anybody heard of Viata? Like a virtual firewall router, so I use the open source version of Vios, and that basically controls all the network segments. So these are all independently routed network segments, and you can have web proxies between them and stateful packet inspection and stuff. So it's all really good. And these are network segments that they run through, and they're fairly routable. So not everything is in the labs that I've built today, but there's about 40 machines of different Windows versions for us to create Sheepl and deploy them on and stuff. As I said, like looking at that lab design, there was always a missing piece for me. And if you look at traditional lab designs themselves and stuff, they're just a collection of vulnerable boxes. And I didn't feel that that really represented what I was seeing in the real world. You know, red teaming is really about attacking people to a degree. That's where the attack surface seems to focus right now. And so I was like, well, this is a really interesting problem. Like, how do you emulate people properly? What is it like with the person within a network? How can I solve this issue? And I started looking around at stuff, and there's lots of solutions for setting up LabSeed type environments. Microsoft have actually got a really cool script, which if you run Hyper-V, you can just run this PowerShell script and it will do all the magic for you. And there's a lab in a box. So there's lots of solutions for this sort of stuff, for creating the infrastructure for lab environments. But I kind of kept on coming around the loops like, yeah, but how do I then add that next layer on? Where are the people? So I started mooching, and I found this University of Amsterdam paper last year, which I read through. Really good, like looks at lots of different solutions for how you can deploy lab environments and stuff. And they're also showcasing their own solution. I've got a lot of time for people like Mark Smeets, you know, Outflank fame. I think they do a lot of really interesting work. But as I read through this, it was basically saying, well, there isn't any way of emulating user traffic. Like, we want users creating documents and creating files and creating data and creating real world traffic that isn't literally just a script making a post request. But there's a lot of challenges with that, really. The first challenge is if you look at sort of Python as an example, which is kind of where I started, it's very difficult to control where your input goes. Things will happen on an endpoint that you're not necessarily expecting, and then because your script doesn't have that flexibility to deal with those types of problems, you can quickly end up sending input somewhere else, and so that means that everything kind of breaks. The other thing is if you don't compile stuff, then you then start requiring lots of runtimes on clients. Obviously you can write C# and stuff and do all the newfangled cool kid stuff. But essentially I was thinking, well, I ultimately want to be able to just put one thing and then that has everything that I need to do. That seemed to me to be the most flexible solution. And then if you want to move away from this predictability, like building in this timing, becomes a real problem. It's a real challenge to build in that randomness and still keep that sequence of events. So I reflected on this for quite a while. And as I said, I'm an old school sysadmin, really. And my company, we used to work with schools. And we used to deploy software for schools, and it was kind of Windows 95, Windows 98 era, where you couldn't wrap this stuff. If you put an MSI wrapper around it, it would break. It just wasn't very flexible. And there was one particular piece of software, Tizzy's Tools, that I had to deploy on a large number of machines, and it was literally a case of going to each one and putting, manually clicking and going through that, which was a nightmare. And all of a sudden that sort of bubbled to the top of my mind, like last year, when I was going through some old files, and I realized I've kind of solved this problem before in a way, or at least the genesis of this problem, through a programming language called Autoit. Has anybody ever heard of Autoit before? Just one or two? Well, I know you have. All he ever hears me talking to him about on Slack is Autoit and Sheepl and stuff. It's like, can you just go and do some work, Matt? Nobody's interested. I'm like, well, I might be able to create a Sheepl that could automate my work, Phil. That's my boss, by the way. So yeah, Autoit has been around forever, since forever, basically. And what it's really good at is it's a freeware, it's basic type language. So you'll see the code is quite easy to read. I'm a self-taught developer. I started with Python, and understanding how Autoit works wasn't too much of a jump for me. So for those with more experience, I'm sure it won't be a problem at all. But it's really good at some of the core things that I wanted, which was controlling the Windows GUI, interfacing with Windows at a class level. So how I solved the Tizzy's Tools problem, as an example, was it expected specific DLLs and specific paths. And it was a case of next, browse, select a file, next, specify a specific path. It was that type of a manual distribution. And I automated all of that with Autoit into an AU3 script. And then compiled that into a binary. So what happened was I had the original binary on a share, and I had Autoit running as a compiled binary, and I used group policy to deploy a startup script, which basically said the very first time the machine runs up, you need to copy down the program installation binary together with my early Sheepl, and then run that to run the other, and basically watch the installation go through. So it's like, this is absolutely perfect, because it can do things like control windows, it can react when a pop-up comes up, it can send keys, which is why we can keylog them, and it's pretty much runs on, I've had it running on all the versions of Windows so far, from XP up to Server 2019. So it doesn't seem to have any real problems with dependencies at all. But more than anything, everything compiles to a single binary. So once you've created this Sheepl and you've compiled it, that executable has the runtime in it, and all of the tasks and all of the input that you've built into this program, all wrapped up in a package that can then be distributed. So I was like, this is absolutely perfect for me. So that began Sheepl. So it's two components, because what I didn't want to do is say, hey, I've written this tool, you just need to go and learn Autoit and then you'll be fine, because I think that's quite a barrier to entry. So what I've done is I've written a Python 3 wrapper around the creation of Sheepl, and it handles lots of bits that you don't necessarily need to know about. Once we get into the code, you'll see it more, but essentially Python acts as the wrapper for that. And I started thinking, okay, well, so I've got a way of emulating user behavior now, but what is it to be a user? What do we actually do? And I kind of come to the conclusion that we spend our day and we have tasks throughout our day. We would, interact with command shells or create emails, open Word documents, etc., or whatever. So it's like, that's cool. These packets of functionality, these modules, if you will, need to be wrapped so that it's fully extendable. It was really important for me to be able to emulate keystrokes. I wanted them to type because I wanted to be able to do things like key logging those key credentials, or when a user copy and paste something to the clipboard. I haven't published a task for that yet, but I've been working on that process where all a user does is takes a credential from something like KeyPass, copies it, pastes it to the clipboard, and then 10 seconds later that is gone, that credential is gone. If you're watching the clipboard, you're going to see that if you have the privileges, and B, you're actually focusing on what type of tradecraft you want to develop so that you're watching what happens to the clipboard, you're going to see that credential, and that may mean the difference between you being able to move on through a CTF type lab environment or not. But essentially, that sort of thinking is like, that's pretty useful for me to think about. And maybe it won't happen again for a couple of days, which is kind of where you can start to see you use this as a foundation for development. And they have an amount of time to complete them, and that can be pretty much whatever you want it to be. For demos and for testing, I tend to reduce it down to a couple of minutes, and even that's not quick enough when you're testing, so I tend to sort of hard code, mess around with the output AU3 file directly, and then once I'm happy that it's the way that I want it to, I'll then revert it back and compile it. But the random time intervals, the entropy in there was a really important part of it that I wanted to build into it so that I wasn't predicting when things were going to happen. And as I said, it can be compiled into a self-contained binary that you can then copy around. It can even self-replicate, which is quite interesting. A Sheepl can copy itself and copy itself to somewhere else and then trigger that action, which is why I said about using it in real-world engagements to create noise across a couple of machines. You can almost wormify if that's your thing. So version 1 was released last year here as a beta, and then I kind of reflected and realized how terrible my approach was to all of this. Like, if you hate your own tool after a bit, then you're probably not in the right path. So over Christmas, I kind of sat down with a good bottle of spirits and really thought, well, if this is going to be where I want it to be, then I need architecture. I need to make it extensible. There was too much if, else, do this, do that, do the other. If you wanted to add in a file, then you had to change it in like 50 different places. It just wasn't cool. And I was like, well, I want people to get involved in this. And if nobody gets involved in this, I still want to make it easy for myself to extend and develop. So I built a different approach to this. So it has 2 modes now, which is an interactive console. And then I've taken it so that you can define a Sheepl in JSON, which I thought was really quite useful for pipeline building, where you want to automate some of this sort of stuff, i.e. in a big project to build lab environments like LabSeed. And now I've encapsulated everything. So I didn't really know too much about object-oriented programming, but I took a Udemy course, as you do, for Python, and I sort of learned how I could encapsulate all of these tasks. So now what basically happens is there's lots of inheritance in place, but essentially if you want to add in a new task yourself, build a new module, the tool will create you the stub code that has everything you need, and you just need to edit that one file. And you don't need to go adding anything into the core because it's dynamically imported and stuff. So that was really, really good. The other thing is I'd written my own sort of CLI for it. And again, it was like, if the command is this, do this. If the command is that, do that. And that wasn't scalable, particularly with the amount of modules that I wanted to build in. And Python in the standard library has got a CMD module, which basically took a lot of that pain away. It handles a lot of the edge cases where something is typed in that you don't necessarily expect and your entire program bombs, and then you've just lost the last couple of minutes worth of work. So it's really good for that. It also means that for every single module, we can have our own customized CLI, which is specific to that. As an example, like a Word task, you will give it an input file and they will type out whatever you supply as an input file. Whereas a PowerShell task, you can give it a command text file and it will assign all of the commands in that file. So this idea that each task can have its own set of attributes and you can write those specifically for that is quite useful and quite powerful. And I didn't want it to be, well, out of the repo, just take a copy of this this template example and whatever, and then make the changes. So I've built the actual generation of like template code into the tool itself, so that you kind of start as you mean to go on, and everything is OCD organized, and tabs, etc. It's quite important, I think, for clean code for people to get involved. And then one that I felt was really quite important, and I banged my head against the wall for quite a while, is this idea of subtasks. So RDP being the one, like I was at DEF CON a couple of years ago, and MITRE were there, and they were presenting Kadira, and they were showing like how you can, on a small network, do things. And they're saying some of the things that are really hard, though, are keystroke emulation, getting users to type, and RDP. And I'm sort of sitting in the back thinking, well, I might have got a solution for some of that sort of stuff. But the point about RDP is, my initial release was it would create a remote desktop connection, it would type in the credentials, and then that would be it. And I was like, well, that kind of sucks. Admins don't really do that in the real world, right? We make a remote desktop connection to somewhere else to do something. And then it's like, well, what is it that you want to do? So this whole idea of like, what would be really cool if like each task could essentially be its own subtask. So you could say RDP to this server and run this sequence of PowerShell commands, or whatever magic you want to create. So this idea of like, well, how can I make that work? And it's stable and it works. I've got some videos and you can play with stuff as well. I think there's lots of more potential there, but yeah, that was quite an important one for me to do, and I'm pretty pleased to say that that seems to be working quite well. And it just uses Python 3.4 and up. So 3.4 is about 10 years old now, so you've got a decade. And the reason that that's important is because it utilizes the pathlib library so that you can run the Sheepl Python part of it on anything. So if you've ever tried to run Python and then all of this fancy import requests, and then you realize that Windows doesn't have requests, so then you have to go through this loop of pip installing stuff, and it all becomes a bit of a mess. So I was like, well, how far can I get with the standard library so that essentially all you need is a Python installation? It means that you can build this sort of stuff on Windows. And the time for sort of unpredictability has ramped up. So in my first version, you would give it a sequence of tasks. It would take that number of tasks. It would say, oh, how much time have you given me to do them? And it would rip those tasks up into a sequence of timescales. It's amazing, isn't it? Well, I'd love to work in that office, just like spending all day building these contraptions, and he's very happy with his outcome. But it baked it in, which kind of went against the ethos of the project, which is I don't want to be able to predict stuff. If you ran it enough times, I kind of introduced that predictability back again, and you seem to be enjoying that, so I'll just keep it going for a while. So in the second version, I've built in even more. So now it still kind of creates a list of times, as you'll see, but it bakes them into an array, and on every iteration, it shuffles that array. And it also now shuffles the task list as well. One thing actually that IR guys that are using it internally have said that they want the option to be able to have tasks in a sequence rather than on every loop it does things in a different way. So for the next version, I'm going to build that back in again with the option for you to specify sequential tasks as you define them, so that it keeps that still with random time intervals. So this is the type of feedback that you want from people that are using your tool. Like that's pretty cool. So why would you even want to use this? Like what's the point of all of this? Well, it creates log entries because they're typing. And if they're trying to authenticate to things, then you're getting error 5s back, you're getting access denied. It creates PowerShell transcript logging as well. If you have all of that on, it's typing PowerShell, so it's leaving that sort of artifact behind. And as I said, forensics guys at work that are building training courses and labs for people, they were like, this is great, because historically we would have a set of bat files that would do things, leave an imprint on the box, and then they'd kind of know. But now they chuck a Sheepl on it for a couple of days, shut it down, forensically capture it, and they have to go through and they find when things have happened because they literally don't know when this has happened. They know that it's stemmed from a call to a binary, but what's interesting is it seems to honor the process tree. So if you look at how you as a user create processes, it spawns them in the same way. So there will always be your sheepl.exe or whatever you choose to call it. But as you'll see, if you spawn CMD, CMD is not spawned as a child of Sheepl, it's spawned as a child of Explorer, in exactly the same way that when you as a user invoke CMD, it honors that process tree. And that's important because of the way we're invocating it. We're control-Ring it. We're running it in the same way that a user would, because to all intents and purposes, we're emulating user actions. So I think that's really, really important in the sense that apart from this weird binary that's running there, you don't see many things. And it's really good for that sort of process injection, stealing tokens. You can run as, anything that you can type basically can be emulated. So at that point, it's really back to how creative you want to be in thinking about, well, how can you invoke some of this sort of stuff? I think that's kind of the fun part. And it creates normal network noise. So, if you look at it from a PCAP perspective, there's HTTP traffic going, there's SMB traffic as they're trying to, access things. It's normal network stuff because we all love shells, right? I'm sure you've seen this sort of thing. So you can put in this sort of stuff where there's an opportunity to exploit something, get something back. And I'm sure everybody's done the interpreter dance. And as I said, before we get into the overall structure and getting access, awesome. There's this child process procedure. So this is how you would normally look. I've got sysinternals access for you on the boxes and stuff. This is a normal process tree. Why is this important? Because if you look at how EDR solutions work, they play a lot of, this is really important to how some of the things get signatured, because why is Notepad spawning PowerShell, or why is Excel calling out? This process tree is quite an important part of it. And as you'll see, as you run some sort of simple Sheepl, there'll be a Sheepl.binary somewhere running, and then as it invokes things, they get invoked as normal. So I think what I'd like to do at this point is, first of all, Philip has very kindly turned up today when I phoned him this morning with the wireless access points, because I've assumed that everybody would turn up with Cat5 cables and stuff, like shame on me. It's obviously the modern era now where we don't really need Cat5 cables anymore because we're all rocking hotspots and stuff. But I realized the first thing this morning that it's probably not going to be particularly useful for you if we've got all of that. And you can't access it. So my very helpful helper is doing this, and in the meantime I'll just come out of this and show you some of the lab, and I think let's get people connected in IP address so that we can route to this sort of stuff, and then some of the people that want to work through some of these demos with me, or just work through the whole thing, that's awesome. So has anybody heard of Proxmox before? One man. It's my favorite thing now. I was trying to do all this with ESX, and it was a complete pain in the backside. And so I've kind of settled on Proxmox as my solution. So I've got the server in a suitcase that I take with me wherever I can. There's about 40 machines running on there. I've got this Proxmox cluster of a single node. And then I've got the VIOS core there, which kind of handles all of the infrastructure. And then I've got just various Windows machines. There's a couple of Kali boxes in the public network as well, if you want to connect to those, or if you just want to mess around with SSH stuff. There's different versions of Windows. So we've got some version 10, some 7s, 2012 boxes for file servers, for SMB. There's a domain controller as well. So as part of LabSeed, I've written another tool called User, which is designed to create massive amounts of Active Directory users with credentials that I don't know and names that I don't know, so that in true sort of tradecraft development, I have to go and explore those. So User's kind of a fairly simple tool. It does use a third-party library, because you can't do this with Python standard library, but it uses something called Faker. And I've got lots of plans for User, but for now, what it's really good at is creating a list of users I don't know about with credentials that I don't know. So there's about 5,000 to 6,000 user accounts in the directory at the moment that you can mess around with, create sheeple, maybe even create sheeple that are looking to enumerate the directory, and think about, well, from a blue team perspective, maybe you want to start sort of triggering on a user that's doing a large amount of LDAP queries, looking for accounts and stuff. It's entirely up to you how you want to use it, but all of these opportunities are there. And then there's a couple of machines that are in different networks that pivot. I've got some web servers in here as well, so if we want to use some of the IE modules to go and visit websites, I mean, why would that be useful? Because of token stealing and injecting cross-site scripting and actually authenticating to things. One of the big pushes in my roadmap that I haven't pushed yet because I'm still working out some of the kinks is that ability to be able to authenticate to web applications and browse through web applications and stuff. So I can do the initial posts and all the rest of it, and now I'm just trying to work out, well, you know, how would I get it to actually interact with a web app? But certainly, stealing credentials for web applications is really good. Tab stealing, beef hooks, all of that good fun. You can sort of play around and understand how all that works. So is there a wireless network available? So if you have a look, there's a wireless network called Sheepl. I'm going to stay off the wireless because I don't trust you. Oh, that's not. Because I don't want to break my Ethernet connection. But you should be able to connect to it, and password is workshop. And what you should get back is a 192.168.77 address. And we'll just have a couple of minutes for those that want to get involved and get a connection. Now, if you've got your own Windows VMs, or you're running Windows, and you want to use that as like an attack platform or whatever, go for it. I'm going to squash this once we finish so we can absolutely nail this thing if that's how you want to do it. Feel free to do very destructive things to the machines if that's what we want. Bear in mind there's only a few people, so there's about 40 machines, so we can go for it. Things I'd like to be able to come out of today are getting them to authenticate to different servers, RDPing around, working out on SSH stuff, because they can do that as well. They can interface with Linux over SSH, which is quite powerful. So I'll get into all of that a bit later. But yeah, so if you've got, you can either use the ones in the labs or you can authenticate. I can give you some credentials for that. But if you then get an IP address, if you go to that 192.168.77.3, which is this, I've put a simple web server up there and I've left some credentials for the boxes. There's some Auto-it snippets in there as well, which we'll get into. There's some software. There's the Sheepl master.zip. As well, and I've also pulled down the latest Python 3.7. So if you're running Windows and you don't have Python and you want to run it from Windows, you should be able to get up and running with all of that. Inside the software bit, there's the Auto-it setup file, there's PuTTY, and we'll get into all of that as well. But you don't have to have Auto-it installed on the endpoints, as I said before, but obviously for development, it definitely helps if you have the Auto-it environment. There's some really cool things and packages that you get with Auto-it. One is a window inspector. So that's really good when you're building these modules and stuff. You can sort of inspect things. And Auto-it can hook at the class level. So I generally tend to hook at a window title, but as you'll see, like, it can inspect everything within the GUI and even can reference buttons which have a class name. So let me put that into context for you then, for how you could build this for tradecraft. Because you can interface with GUI elements at a button level, let's say that you want to test the ability for detecting when somebody enables a macro. What you could do from a tradecraft perspective is have a Sheepl that sends an email to somebody that's going to open that email, okay? And the body of that email could be the first logical point of inspection. Let's say that the Sheepl, the attacking Sheepl, is designed to send it to somebody in HR. If the context of the message is nothing to do with the person that works in HR, it's not relevant, bin it off. That's it. If it passes that first check so that that phishing email is relevant to that person, or maybe has some information from the website, or there's a correlation, then we'll move to the next step, which is to open the Excel spreadsheet that you've sent with a macro inside it. Stage 2, open the Excel spreadsheet. If it's a blank Excel spreadsheet with nothing in it, we'll bin it off, because it has to have context. It has to have some sort of call to action. And then if we pass that check, at that point, you can then either move the mouse to click on the GUI control, or you can just send the click at a class level as well. So that's a really granular focus on how you could use this. But I think that's my opinion is that that's really powerful, particularly from a training perspective, when you're trying to take a person and say, okay, these are the things that you need to focus on when you're developing tradecraft. Emails have to be well written. They have to be relevant to the person that they're maybe not even the first one. Hey Debbie, hope you don't mind, but I've just sent you this toteslegit.exe. Would you mind just running it for me, please? I mean, that's not the real world. So that builds that enforces that complacency that I said before. So we have an opportunity to explore that and trigger off the logic of that. And then the same thing with crafting payloads as well. We can have that logic inside it to say, well, if it meets a certain set of criteria that we're trying to foster as tradecraft development, then we can take an action based on that. So it's not machine learning, because they're not going to work it out for you. It's you planning how you want to develop, right? It's you building the ingredients for what you're going to make for dinner. You might have a cupboard and there's lots of bits, but at some point you know that you're going to eat, and it's going to involve some ingredients. I mean, I can't cook, so you probably wouldn't really want to come around my house. It would be baked beans and golden syrup, I think, with Jacob's crackers for pudding. So that's the point about all this. Like, people kind of come back, I'm like, the onus is on you to think about how you want to develop. But then once you get that into your head, the possibilities for this are really quite broad. So I'll just show you the VIOS box as well, just so that you've got the context of the lab. It's the default cred, so if anybody kills the VIOS box, shame on you. But it's a really good solution for these types of lab environments, because it's essentially a router and everything that I need all in one place. So I can show you all the interfaces. There's a couple of network segments. You can stack these things as much as you want. What the VIOS solution does is it defines all those modes. It acts as the DHCP server for all these segments. So when boxes are stood up, they automatically get all the correct DNS stuff, and they can all talk, etc. So it handles that for all of those. It listens on SSH. It acts as a web proxy that I can bind to different addresses as well. So let's say you want to be focusing on clients that are coming back through an authenticated proxy, and you want to develop all of that tradecraft type stuff. We can do all of that. And then there's just some package management stuff. So I really like this. And in the true sense of that automation procedure that I spoke about, I've now got it so that VIOS, the config of VIOS, is completely unique every time I build one. So I don't even know what the IP addresses of the network segments are going to be, and how that's laid out. I have to go and enumerate this thing. I have to find out what the IP addresses are of the segments, and I have to focus on tradecraft. So is everybody, the people that, have you managed to get an IP address on the network? Yeah? 192.168.77? Yeah? Let's just check. Yeah? Addresses? Okay.
But I get to that people that contacts the 6.
Oh, that's weird. Something's blocking your connection. Saying like firewall access is blocked, your internet access is blocked, firewall antivirus software may have blocked that connection. So I think it's something aggressive. Okay, cool. So if you want to pull down the environment, like get yourself a copy of Sheepl and then get yourself installed, whether you run it on Windows or whatever. I've actually got it on the Mac, so let me just come out of this. Oh yeah, that's the other thing as well. You can see what's really useful is because I'm running VIOS and I can connect to that, I can see all of the addresses of stuff. So we can see things coming through now. So anybody that's interested in DevOps and lab environments and stuff, this is a cool way of doing it, I think. Okay, so let me go into Spider Labs, Sheepl. So I'll go over the folder structure actually first in VS Code. Let's do it properly from the very beginning. And if this isn't big enough, then please feel free to shout and stuff. I've also got the beginnings. You're seeing the kind of the yet to push to GitHub version, so you kind of get an idea of some of the other things that I've been doing. Lawrence said to me, like, you can't write at all without the option of having a GUI. Like, you can't assume that everybody likes to work in the CLI, plus you're building Windows, like, GUI interaction, so you need to go make a GUI. And I was like, actually, he's right. So I've been working on a GUI for this as well, just for just making it easier, and also building this into a bigger pipeline. So the lab seed example where you create vials and you create all these machines, Sheepl will be a part of that. So you can say, oh well, I want Sheepl that do X, Y, and Z, and that's why the JSON profiles part is really important. But let me just close all this out so that we don't get distracted. Quite a lot of code, but hopefully you'll see that I've taken the time to try and keep it fairly clean. So there's some utilities and stuff in folder structures. It all runs from the root downwards, so Sheepl as being the top level. You can see it imports all these bits and pieces, and all that really does is passes in the arg pass stuff, a couple of checks, and that's it basically. Everything that happens from a tasks perspective is inside this tasks folder. And I've started to imply a category-based system already because I was like, well, I want them to have lots of things. I need to organize it. So I'm using the folder structure almost as a category-based solution. And then, you know, it's easy to add in different types of categories, as you'll see later on. But we have this structure. So if I take, for example, the shell, I've been pretty strict in terms of how the naming conventions of the files come in, and that's quite important from the task list perspective. So it is like uppercase for each network segment, etc. But if you look at the command shell one, if I just get rid of that, again, I've been really pedantic about the structure of the files. This is all template code, and I wanted it to be really clear so that people could see how it is. So you get a Sheepl object, you create a Sheepl object, and then these tasks become attributes of that Sheepl object, basically. And there's, for each of these task structures, there is like the base console itself, where you define all the bits and pieces about how the command works. And then there's the meat of the task itself in how it actually interacts and how it builds all that sort of stuff out. You don't really have to make too many changes there. And then the biggest bit is this auto IT block down here, and this is where you define all of the actions in terms of how it starts, whatever it is you've asked it to, how long it waits, how it invocates things, you know, what it's looking for, and how it passes that through. So I'll show you it in the context of the actual program. So Python 3 Sheepl interactive. Actually, I'll just show you so there's a -help, and you can see that I've started building in. Is that big enough for people at the back? Yeah, I've tried to go for big styly text. So there's a couple of things. No loop. So I just assumed that everybody would want these things to loop over and over and over, and then somebody went, I don't want it to do that. I want it to run once, and then that's it. So there's now an option to remove the looping part of things. So once you run the binary, it will go through that sequence of tasks randomly once, and then it will just never run again. No color options and stuff. Tray icons is quite interesting. So if you want to use this to build something a little bit more aggressive, you can hide the tray icons. I've left it in by default, but because Sheepl will pop up as a tray thing, but you can remove all that. And then there's some information about profiles, and as you can see down here, like a template creation engine that creates that stub code for you. So in interactive mode, which is where I spend a lot of my time, actually, the first thing that you do is you have to create a Sheepl. If you try and assign something before you have a task, then before you have a Sheepl to assign it to, it's just going to bomb out. So we create a Sheepl, and then how long do you want them to take to do stuff. And you haven't defined what you want to give them yet, just how long is it going to take for you to do things. So for testing and messing around, I generally start with like a minute, and then I'll go back through again and do it that way. Typing speed. So by default, through testing, I found that 40 milliseconds seems to be quite fast typing, but fairly sort of natural for a proficient typist. They can type perfectly, which I'll get to a bit later, and I've got some Auto-it files to show you how I want to break that up as well. Because if you've ever tried to keylog somebody in the real world, I am terrible at typing. So I would imagine anybody that's keylogging me, they're trying to decipher the billions of backspaces that are in the actual clean output. And I was like, that should be in there, right? That's real world. We should do that. We shouldn't have a perfect keylog. We should say to people, there's like, I don't know, 20,000 keystrokes. Fish through that for me, please. You'll find some creds in there and go through it. So we can specify this sort of stuff. And segueing and bouncing around. I also like the idea of having this typing speed as profiles. So you have like the PA that can type nearly perfectly at like 120 words a minute and very rarely makes mistakes. And then you've got like my old IT boss who was like a chicken pecker that would take like 3 weeks to type a word, and that's lots of backspacing. So I think that's relevant as well. We have, we're kind of personalizing the types of Sheepl that we create that ultimately leads into a more real world experience. So at that point, we are into the realms of, we're now in the context of that Sheepl. And the CMD solution's really good because it dealt with a couple of the bits and pieces that I missed before. Like you could bomb out at this point, or you could end up creating things that don't exist. So for example, if we list, that's currently all the tasks that are inside that folder structure. Okay, I'll show you how we can dynamically import things later. But those are all the things that they can do at the moment. The key pass one, I haven't yet pushed it. So some of this is for my local, but if enthusiasm appears after this workshop, then I'll definitely be kind of pushing more bits and pieces. So that's what they can do at the moment. But for example, you could accidentally mistype something and it would go, oh, okay. And at that point, it now thinks that that's a valid task, even though it doesn't exist. And the whole program would die and people would send me abuse on Slack going, you're rubbish. So CMD handles all of that because even though it's there, it doesn't bomb out. I just can't do anything with it. So I generally start with command shell interactions because I'm generally trying to emulate admin users. Okay, so as you can see now, the context has changed. So we're now inside a command shell interaction. And if you help, you can see this is all the stuff that's specific to the command file itself, to this particular task. We'll get to that later. You can define whether it's a subtask or not and stuff. But all of this help just gives it that kind of feel of CLR type interaction. But if I try and say, okay, I want you to type ipconfig, it says to you, you need to start a new invocation of that. Because what I found was that I would go into a command shell task, I'd create one, I'd complete it, and then I'd want to create another one. But I'd have to go back out, back in again, back to that guy smelling his own hand. I was like, this is terrible. You need architecture. So you make a new invocation of that. And now at that point, it tells us what the IDs of that command shell that we've created, right? And you can see that in the code arrays. These are the actual names of what basically ends up as Auto-it functions. That's what it gets called. And then at that point, we can basically type anything that we can run inside a terminal, because it will start CMD for you as part of the task module itself. And then it will, do enumeration, and you can sort of keep a track of where you are as to what you've assigned to this user. You can discard stuff if you've decided that that's not what you want to do. And then at that point, you can bomb out it again. So at this point, I kind of go, well, it's up to you. Like, what do you want to do? What do you want to execute? How do you want to do it? You can do a lot of things. Anything that you can type can be emulated. So it's really about, well, what do you want to type? Like, what is your special foo that only you know how to do, or even your own way of doing things? How does that look? What does that look like for you? And then you can just encapsulate that. So at that point, you can go, okay, well, I'm going to complete that or discard it. But if I complete that, that completes that task. And now I have the opportunity of going back to the task list, or I can create a new one and do the same thing again. And of course, all of these, like you're calling who am I is going to be a child of C and D in the process tree when it's called. So anything that we're triggering here honors that process tree. And then at that point, we can just complete that and then go back again. And then it's just rinse and repeat, right? Just looking back at what the task lists are and what types of things that I want to introduce. So the C and D one's really good for even using run as. I'm actually going to create that as its own module, as you'll see later. But, that's pretty cool stuff. Process kill, I've built some sort of capture the flag type things that you've got as snippets. We'll go through all that as we get into it a little bit more. But at that point, I now have options to keep on like smashing up the task lists, or I can finish. And at that point, it takes the total number of tasks that we've assigned, it takes the total amount of time, and it does some like chopping up in the background, and it creates some sleep time arrays, and then it adds those arrays to that file, and then it writes this 44com_workshop.au3 file. Now at this point, you can't just run that as a binary. That is the autoit outputs. You have to compile that with autoit, but I've got some pipeline stuff for that as well. You can run it on wine anyway, so you could essentially just bolt on a process where the profile gets hoovered up, it creates AU3 files, then something loops through that AU3 files directly, compiles them all to binaries, and then distributes them through the network as group policy. And if you build in entropy to there, you might not even know which machines are running the types of Sheepl that you've created. So now you have to go and try and find those users that are doing the things that you've added in. Fair enough, you've added that moment of opportunity that I said before, but you don't know when they're going to do it and on which machine they're going to do it. So that's probably about as entropic as you can get, really, if that's even a word. So if you look at this output file now, if we open that, out of tasks into output, okay. This is what it's just created for you, and this is why you didn't have to go and learn autoit, essentially. So it's a little bit like Python. It brings in its own modules. Now it has a set of standard libraries. If you can keep, if I start getting crazy on time, we're a couple of hours, aren't we, for this? So it's 10:30. We're all right for time for a bit. So it has its own standard libraries, but you have this concept of UDFs, where people can write their own libraries as well, and you can include those. And there's some amazing UDFs. There's a guy called Water on the autoit forums, and he's written things to interface with Active Directory. He's written a whole client for Outlook that can do everything that you can do in Outlook. So I haven't included those yet, because they're sort of outside of the standard autoit library. But it certainly means that it's extensible and we can sort of look at this sort of stuff. But you can see we're doing a couple of things. We're bringing in the arrays and the Win API. So it can interface natively with the Win32 API. So already pretty powerful stuff, right? And at the top, as you can see, we've got it creates two arrays, and they have to be bound arrays. So they have to be defined length. If that didn't have a 2 in it, that wouldn't work. So you have to be explicit, which is kind of why I handled all of this with my Python tooling. And what happens is there's a while loop that it goes through. It creates a copy of the array. I'm still not entirely sure why I did that. But it takes it shuffles it on every loop. So this while one. Now, there's no concept of object-oriented programming autoit. So you can't do any of that sort of stuff. And you can also only have one explicit while loop. So you couldn't nest something else inside there. At least that's what I found. So this is kind of like your main loop, and then everything happens in there. What you can do is define functions that then get called as part of this loop. Okay, and I've just left some CLR rights there just so that we can see it running. And then this is the declaration of that function. So it comes in, It defines how we start it, so it's literally sending Windows key and R, because you can emulate that, and then it types out CMD and it sends enter. It creates at the class level, it makes sure it gets a handle to the window, and it hooks that window. So that seems like a trivial thing, but that solves a lot of the issues with something taking focus, and all of a sudden, you losing where your input is going, because it will create that CMD file and it will constantly check to see if it has a focal handle. And if it doesn't, it will take that focus back. So you can minimize stuff. And if you've told it to send a command, if it's minimized, it will just unminimize it and continue with the command. So I thought that was really useful in solving that problem. And this is some of the subtask stuff that I've done to check whether you're inside a remote desktop session or not. And then these are all of the commands that I told it to type out. I've built in some arbitrary sleep times into this, so there's a 15-second delay again, but this is all kind of hard-coded in terms of it does it once and then it never changes. So there's, we can improve on that for sure. And then there's the second one. And all it's going to do is it's going to loop through those two task lists and it's going to select. So because these are fairly long wait times, I'm going to just manually make that 10 seconds for that one so that we're not waiting too long, and 5 seconds for that one. Okay, so we've got our AU3 file. Let me just go back to my Windows box. And I'll just start this up on my local and then we can get things going in the lab. Okay, so if I open that file that I've just created, 44com workshop, there's the file there. I'll leave this window open so that you can see. There's the edits that I've made. So this is the SciTE. This is the editor that you get when you install AutoIt. And it's really useful to have this because it's got code hints and it allows you to compile on the fly. I've got the extended version, which supports like millions of languages, but it's pretty good. And it gives you other options like how it compiles. You can specify different packers and stuff. So there's lots of options there. But for now, before I compile it, I'm just going to run it. So it comes in. You can see there's those console messages that we said. It's going to go around the loop for 6 seconds. And then it invokes CMD. And it's running whoami/groups. And that's all being typed. And then it's going to exit out of that. And it's going to wait again. Yeah, and then it's going to go through and it's going to sleep and then it's going to wait for the next task, which is just the other CMD file that we did. So now it's running ipconfig. I can't remember what else I wrote, actually, net user, I think. And you can see like that's that 15-second delay. It's like, come on, come on, come on. I spend ages waiting for them because I've realized that I've kind of made that a part of the tool. But running net user commands, again, from a review perspective, you can see all this sort of stuff, right? That user has just run that command. Matt on this machine has run that. And it will just keep going forever. So whilst that's running, if we open up Procmon, oh no, not Procmon. Stupid. Process Explorer even. In fact, I'll just stop that for a second, because otherwise you end up typing it in places you don't want it to be. Let's get rid of that. So, if we move this over. Actually, what I'll do is I'll compile it for you, right? So, tools, compile. Where we're going to put it, I'll compile it there. It's an exe. So AUT does all that for us. And then what we end up with in this folder is, it says, hopefully, 44com workshop application. So this is about a meg, because it's got all of the stuff inside it. You can do loads to that. You can specify packers and you can reduce the file size and it can clean up code and stuff. But essentially, to all intents and purposes, if I copy that and chuck it on my desktop, that's it. So when I run that, although you don't see any console output, I don't think it's very small here, but in the bottom right-hand corner, there's the tray icon kicking off. And there's all that. And if I minimize that, if we look at Explorer, there's the 44com workshop, and I'll just leave that open so that we can watch the process tree unfold. You can see that CMD file is minimized at the moment, right? So it's lost focus for that. But it should, see, it snaps back. It's like, oh, I've got to send another command to it, so I haven't got that window handle at the moment because Process Explorer has got that, so I'm going to steal that back again, and I'm going to continue with the commands. So that is really, really useful when you're trying to build bots, because you know that it's going to do what it's supposed to do, and it will keep on going. So if we look here, I don't think I did netstat actually. Let's move it over. And if you start messing with stuff and you can kill it like I just did then, the idea of this is that you create it and then you just leave them to run. Because if you try and sort of interact with it whilst it's going, I don't know whether the process that I've chosen at the moment is going to show you that tree. But you can see that CMD is not a child of 44con, it's a child of Explorer. So on that point, we've got that process tree going. Yeah? So because it's running as that, you have to hard kill it. So that's something to be aware of, because it's now a binary on a loop that is no longer in a scripting environment. It's compiled, and it's pretty bulletproof. So it will just keep on running until you hard kill it, which is exactly what you want, particularly over long periods of time. So I think, where are we in terms of the presentation and timing? I think what we should do now then is let's start creating some stuff, right? Let's have like half an hour or so. I can help you get into the environment. There's different Windows machines there. Create some things, malicious or not. See how you want to go. Look at the PowerShell stuff, and then I've got some examples of things as well. And yeah, we'll just sort of build them and see how we can go with that. So this is what I've written. Basically, there's a Word document. You can see that it applies to the Office on there. A command shell one as well, and then a PowerShell invocation to kind of get into showing you the types of things that you can do with it. So if I step through the file first of all before I actually run it for you, you can see that this is essentially going to open, it's going to spawn Word, and then it's basically going to start typing out all of this sort of stuff. And you'll see that I'm kind of now starting to get into the realms of formatting. So because we can send keystrokes, we can do things like selecting all of the text and then making it H1s. And we can start getting into formatting and kind of making it feel more real world. So you'll see all that. And that's handled through, you can see these send chara exclamation. These are auto-it language declarations that have a wildcard key that are assigned to certain things like Alt or Control or something like that. So you can get quite clever with that stuff. I'll scroll down. So that's the Word one. And then we move on to a command shell one, which is fairly simple. I've already shown you that sort of stuff before. It's just IP configs and netstats and whatnot to show the process tree. And then we get into stuff which is a little bit more interesting in terms of attacking. So we've now got this PowerShell invocation. And what it's going to try and do is it's going to enumerate all the running services through WMI, and then it's going to try and start a bits transfer from 44 from this here to the desktop. Basically, it's going to try and download those files using PowerShell, and then it's going to attempt to do those. So I don't know how this is going to work, because this malware.exe is actually a Sheepl that I've created. So things could go really wrong here, but that's the compiled Sheepl that I showed you before. So essentially this is now sort of self-replicating. You see malware.exe is basically the 44 workshop.exe renamed to malware. So we'll see how that goes, and we should see the hit come in here on 8081. Let's just check that can actually root to that before it all dies. 127.63. Yeah, they can at least see it. So let's see what happens. Again, I'm not going to bother compiling it. I'll just let it run so that you can see it in situ. We will have procmon running in the background as well, just so that you can see how things are spawned. think we're good to go. I've hardwired the times in to be fairly short, 9 seconds and stuff, for the sake of demos, really. So I don't actually know what the first one's going to be. Oh, it's chosen PowerShell first of all. So this is V5 because it's running on my Windows 10 box. So in terms of malware and doing download cradles and stuff, then you can trigger AMPC, because if you try and do a download cradle, you'll see those warnings. And if you've got script block logging enabled, you're going to see that in place already. So you can see it's just done a bits transfer to the desktop of malware.exe, and it's going to do a bits transfer of the 44 Connect. It's done that as well. It should get the content of that, hopefully. Okay, so that is the text file. So this is just PowerShell at this point. Anything that you can type in PowerShell is going to be the case. It's now going to attempt to run the other one. So let's see. That ends, but I'm not sure whether it's triggered the other Auto-it one. It may or may not have done, but that's just a gimmicky thing. What I did before was I left that as Cobalt Strike. It was a default Cobalt Strike binary, so that it lands on the desktop as a bits transfer, and then Defender goes, whoa, you don't want this on your desktop, starts a whole process of remediation and cleanup, which then leaves a whole event trail. So even if you just want to see whether you get your AV events that bubbling back up the top to the SOC or to the SIM, you can do it for that. You can deploy a Sheepl, get it to sit there for a while, and then get it to download some malware to the desktop and see where that, first of all, the AV triggers it, you find it within your logs as to where it is, and whether that comes all the way back up to somebody that needs to be like, hey. So this is the Word one. So this is kind of gives you an idea of where we're going. This is just geeky, really, to be honest, but if you're screen grabbing, screenshotting, video watching the user's desktop, I think all of this sort of stuff just adds to the realism. It looks like a user's typing it. And I really did this. If you look at the top, you can see it will be switching between the title and formatting and stuff. What is also interesting about this is the way Auto-it invocates Word is it's got its own API calls. So next time you have an opportunity, create a Sheepl that runs Word, then look at the process tree, and WinWord never actually spawns, because it's done it through like a COM object, I believe, or something. So winword.exe is currently not appearing in the process list, which I find mind-boggling and intriguing at the same time as to how that can be useful. But you can see we can create links and all the rest of it. And as I said before, I dropped in a password into that, so the user typed a password. And because we can keylog, you can get those credentials as well. So that's just a bit of an idea of what else you can do with this sort of stuff, building up the tasks over a longer period of time, making them richer. So it wants to open another Word document. So that's pretty cool. You can see there's all the gets, so it can come and get stuff, particularly through a bits transfer. So that's a nice attackery way of getting things through, i.e. download cradles will work as well. So you can get them to sort of emulate attacker feed a little bit as well. And if I go back to my PowerPoint Prezzo, what we're really talking about is MITRE, right? I mean, I'm sure everybody in the room is aware of MITRE now. I think it's a very useful framework for this sort of stuff. I won't bore you with the attack, but I like this idea because I kind of bounce back to, well, what can I actually make Sheepl do? Is it possible for me to email and send stuff in as bots? And I think it is. And we've already proven this morning a number of times that we can interface with command shells and command line stuff. Can we manipulate accounts? Well, you can steal tokens, you can inject into other processes, you can do that sort of stuff. Certainly, creating processes in the context of other users is quite useful. Bypass UAC through exploits, etc. You can use it to trigger that sort of thing. Messing around with your group permissions, certain enumeration. Is very easy, net usering or WMI against either the local machine or a wider Active Directory is quite cool. And then it gets into clipboard data. As I said before, that's quite interesting to think about. And then how can we get stuff back? So as I said before, I haven't pushed too much yet, but this idea that they can make GET requests to servers, etc., but they can also make POST requests as well. And in the Auto-it snippets, you'll see that there's a couple of files in there that are pretty much straight from the Auto-it directories. that do things like either operate at the iNet level, so they'll use Win APIs to interface with iNet, or they can create sockets and they can do it over that level. So there's different ways that you can interact. So realistically, could you use this for like a rudimentary sort of C2 back and forth? I think that you could definitely get there's a potential for a bot here if that's how you so desire, and then sort of build this chain of attack to see whether it comes through. But importantly, that malware call that I just made, that is straight out of MITRE. Like that is a technique ID from MITRE, a bits transfer. So from like the blue team perspective, this is cool, right? Because you can go, how can I emulate? And I really like Atomic Red Canary, and I think they've extended the solution quite a lot now. As I understand it, they have YAML files and things where you can pull down these sorts of techniques and you can run them. But I was doing this kind of before that project was extended a little bit, and I was very much going, well, how are people executing MITRE attack framework commands? How are people doing it? And the common way is like bat files or bits and pieces that just kind of create things at a moment in time. But it goes back to that complacency that I said before, because you're like, right, have you got your sensor ready? Have you got your sensor ready? Everybody ready? Execute the bat file. Everybody see that? We've got this APT thing solved. And I'm like, well, yeah, that's cool. And that definitely shows whether those events bubble up. But there's no noise around real world normal network traffic in that. So what about, that module does that bits transfer and then it sits there for 2 days before that final call comes in. So I think this is all quite useful stuff. So has everybody managed to at least, you tell me what you need. Are the machines you want to access? Do you want to just keep on going through this and I'll show you the capabilities? I'm not going anywhere, so this server can keep running. Feel free to, keep smashing away at it and stuff. It's entirely up to you. But I want to try and give you the whole oversight of the project so that, you can hopefully use it for your own benefits. So on that basis, I'll move on to subtasks. This is a good place to sort of look at how we extend it through. After I show you one more thing that I think is quite useful. So there's a couple of things here. We've got like a responder type attack. So we can program Sheepl that are looking for paths to servers and things that then are incorrect, that we can then respond to those. So I can set that up in the break and I can show you how that one works. I've got a process killing solution as well as a fairly advanced one. I'll get to that one in a minute. But this is quite, I would consider the next steps of looking at attack. Output, compiling C#. So there's no sort of real difficulty here. I've basically got on the desktop of this machine a very simple hello world C# program. There's nothing to it. It's literally just we'll open it. It's just hello world in C#. But this idea of using the on-box compilers to pull down text files and then compile them, I'm sure everybody's aware of that sort of stuff. And we can use a Sheepl to do that. So it depends on how you want to get the text file down. So you could use all of the other tasks beforehand. You could use PowerShell to do it as a bits transfer. You could use IE and actually download it directly. However you want to get that on the box, there's a lot of ways forward. But then at this point, it's stuff that I've been showing you all morning. It's creating a CND task. It's specifying the path to the C# compiler with the C# source code, and then it's compiling it. So let's just run that just so hopefully that starts to plant some seeds about... Oh, thank you. So I've been talking all that time and you didn't see any of that at all. Yeah, so this is the Hello World C# program, really simple, okay? And all I'm doing here is I've created a command shell task, and again, as I said before, anything that you can type. So command shell task, and all it's doing is it's specifying the path to the C# compiler on this version of Windows. Now you could enumerate that, okay? You could do some initial checking to see whether it's there beforehand, but essentially this is the path to the C# compiler on most of these Windows versions. And then the source code and what I want to output it as. So I'm just going to basically output it as hw.exe. So now we're using Sheepl to grab C# source code to compile it on the box at some random point that we specify. So if we run that, there's a 14-second sleep, so we'll just let them do their thing. And you can see there's a theme here now, right? I'm always kind of launching from a command shell, path to CSC, the file itself, and that's it, it's compiled. So we've just pulled down a payload and we've compiled it in real time, and then it exits. So I'll stop that. Open up CMD, go to the desktop. So there's the thing that it's just compiled, 1114, and if we run that, hello world. So I think that's quite cool because this ability to pull down like C# shellcode and stuff and have it sitting on the box, and then MS build is another example. All these sorts of things that are in the attack framework and are sort of well-known attacking type scenarios, pretty good to explore, I think, as a mechanism. Yeah, so the other thing I want to show you then is this process killer. Now I've written this by hand, so I haven't pushed this through yet, and this isn't really in Sheepl as such yet, but it will be. So this idea of OPSEC and how can I improve my tradecraft, and what types of processes am I actually spawning? Are they well signatured processes? Do I want to look for them? As an example, like Cobalt Strike is well known for, as one tool that I use, is well known for run DLL32 spawning or PowerShell invocation all over the place because of how it does its injection, etc. So I thought, well, that's quite interesting. I wonder whether I could almost write like a little EDR solution that would go through the whole process list and look at the process list, and if it found things that I wanted to key off for tradecraft development, it would either have levels of that's terrible OPSEC and it just kills it straight away, or gives me a couple of chances and it posts it somewhere to go, this process is still running 1 counter. This process is still running 2 counters. Third time lucky, this process is still running, you need to consider OPSEC, kill. So that's basically what I've written now. So this is essentially a little bit more complicated. You can see that there's lots of functions here for looping through the window. I didn't write all of this, or to it. Forums and source code are great for that sort of stuff. I've written some of these counters, etc., to just check through. It's pretty Python-like if you know that sort of stuff, and you can see OPSEC. So if I maximize this window, because this is where you'll see all the output, and let's run that. At the moment, we haven't got any processes that it cares about. I think it's just in the array, it cares about PowerShell, Notepad, and IE. And you can see there's a message there, PowerShell, common process, look at your spawning. So let's go and run that. Okay, so the hard-coded counter is like 5 seconds. So every 5 seconds, it's going to pass through that list and it's going to be looking for those processes. And if they're there, then it's going to kill it. So let's start PowerShell. It should see PowerShell. Yeah, so found PowerShell, it gets the PID. It appreciates that it's a common process that we need to be aware of. It adds 1 strike. And then once you get to the 3rd time, it's like, hey, this isn't something that you should be running. So it just kills it. And it will do it if you look at how people spawn, like a box that somebody's beasted, there's like processes everywhere. I'm sure we've all seen that. So that's a ton of PowerShell now running. And you can see it's found all of them. And originally, because I wrote more than 3, I'm quite happy to publicly disclose my crappy code. If I did more than 3, it just went, 1, 2, 3 PowerShells, kill. And it was just like, that's kind of not what I'm trying to achieve. So it goes through and it gives you, if it defines any PowerShell, it doesn't matter how many processes are running, that's one strike. So, we can kind of tweak that. And then it goes through and it's grabbed the PID and it's killed it all again. So I think this is quite powerful as a tradecraft development tool, having this sitting somewhere on a box that you want somebody to land on, or maybe just having them distributed as boxes. And you're like, well, you need to look at how, from a red team tradecraft perspective, how are things being detected? What are the types of processes that these EDR solutions are signaturing on? Do we want to spawn those processes? And then how can we develop tradecraft to steer people in the right direction that those aren't the sorts of things that they want? Same thing with Notepad. So my ultimate goal is to have it so that this information that's really being pushed into the console at the moment gets pushed somewhere else. As part of that sort of lab seed scenario, they post something back. So I thought that was quite interesting. Yeah, think there's some mileage in that? Good. Feedback. Synac. Reset. Okay. So subtasks. I'll just show you the video for this one. I think it's easier for now because it's easier to talk over. But yeah, this is cool. So I'll just play it. We have this client that's in the environment. There's an RDP file on there because I want to get you to start SSHing around now as well because there's Linux boxes you can issue commands on and stuff. So same thing. So handles all of this. So all of these are kind of grabbing the insights into what computer I need to connect to, what the username is, credentials that I pass. Handling this Windows security window is quite important as well because that's a pop-up, so now technically we've lost focus. So you need to be able to react to this sort of stuff. This as well, because I've connected to it via an IP address. It's not a fully qualified domain name, so you're going to get a certificate error. How do you deal with that? Well, like accessibility plugins, _ so you can send all of these as key commands. So we can go, oh, okay, I'll wait for quite a lot of time here, but you can send that yes. Now, essentially, we've now made a remote desktop connection. You could have keylogged the credentials as they were passed through, as I'll show you in a second, but we're now on the remote server. So there's a caveat with subtasking, is that everything is now available, but you don't really get the insight in the same way, because what we now need to lock on is this entire terminal services window, because something else could take focus and you could now not lose access to the program that you're trying to connect to, but the entire GUI. So at this point, we're constantly checking to see whether we're inside a terminal services class window, and it hooks on that. And as long as it's there, then it will just send the other commands that you have asked it to do. So that's basically what it's doing here. It's just like running some PowerShell stuff, chucking it to that date, working out what the version is. But again, at this point, this could be anything. So you could remote desktop to a machine and then start running using PowerShell as an example to execute commands or whatever it is that you want to test. Test whether AMPSI is actually working or whether you can bypass it, all this sort of stuff. And that will just keep looping. That getting out of that window was a really difficult thing, because if you've ever used RDP, it automatically takes focus. So as you're typing commands, now all of your keyboard is almost redirected into this session. So the question for me was like, well, how do I get out of this? And it took me like a week or so of serious Googling to find out that if you press the caps lock key, I believe, that for a very short amount of time breaks the focus of the remote desktop window and momentarily sends focus back to your local keyboard. And in that moment, I can then snatch that key and send the exit command for remote desktop. So that's how I've done that looping, because obviously I want them to authenticate to remote desktop, do some things, exit out, wait for whatever period of time, authenticate back in again and stuff. So around we go. Typing is really good stuff. So that's the key logging from Cobalt Strike on the client that I had that running. That's key logging at that point in time. So as you can see, there's all the alt commands that it's sending to answer those questions about, do you want this, do you want that, do you want the other? That's the credential for the user and the user's password. So there's the Windows security title that we saw pop up. So you can grab that at a class level for that window, and then you can send the password to that. And then at that point, all you see is that you're inside a remote desktop connection. So you're no longer keylogging on what's been typed into remote desktop, because you don't have a process visible in remote desktop, if that makes sense. Yeah, because what you're catching is the invocation of creating a remote desktop session, and that's why we've got all of this stuff here. But then once that, you're not seeing any of the PowerShell stuff anymore, because that's inside of a remote session that you don't currently have visibility of. Does that make sense? I know that even though you're typing on your keyboard, but to all intents and purposes, you're keylogging Explorer locally. And what you need to be keylogging is Explorer remotely if you want to see that whole PowerShell thing. So it's a bit of a brain melt to understand how the keyboards get redirected, and I still don't fully understand it, but I am pretty confident that that's the reason why you don't see that moving forward. So it's pretty good from a tradecraft perspective. You can see caps lock, caps lock, caps lock. So it sends caps lock a couple of times to break that focus on the remote desktop session, so that then you can come out again. So if I show you some other bits that I've created, and then I think make some more tasks, if you've got visibility, if you've got the mechanism of connecting to the remote machines, then you can see that sort of stuff yourselves as well. So let's just go back to Sheepl. I'll do it in interactive mode again, so that you can see some of the... So we'll take 1 minute. You can type normally, and then if we list the tasks, there's this putty connection. So if we use that, see what I mean about typing? Backspace, backspace, backspace. If you're keylogging, you can see all that, and I've actually got a demo of that to show you. So the same thing now. You can see I've tried to keep a standard for the module. So you always start with a new invocation, and this one has different things because it takes credentials, it takes a command file. So the putty connection is quite a more advanced module, or it has more stuff to it, because you need to know what credentials are there at the moment. If we have a look, we haven't assigned any, so I wouldn't expect that to be the case. Also, if you're running on Linux and you have the readline library installed, GNU readline I think it is, you get tab completion for all of this as well, which is quite helpful, but Mac doesn't have that support. So at this point, we can specify, well, credentials, and then we want to log into this machine. I think it's that one. We want to use server admin, and we want to use the password. Okay, so we've started that. Now if we show those credentials, they should all be there. So that's now baked in as something that's going to be passed to the output of the module. And so then at that point, we can start going, well, let's assign some commands. Just insert whatever command you want to type, okay? You get the point at this point. So I can complete that. So if you want to download the latest dirty cow, compile it on the box, try and get root, execute as root, all these sorts of things you could mess around with. So at that point, we can finish that. So we've got this SSH guy. Now there is a bug that somebody submitted, that the third issue, the first two issues I submitted to my repo, and then I noticed a couple of weeks ago that a guy has issued a bug for this putty right here. And when I first tested, I was like, I can't replicate that. And then this morning, before you guys turned up, I actually replicated it. So I think it would be useful to show you in real time. It doesn't happen the first time either. It's only when it loops. So it's pretty good to show you where the bug is, and then obviously I'll have to fix it as well because it's publicly recorded. But you can see how this sort of stuff works, and how, if you're not kind of walking through how the windows get mapped, you can get lost quite quickly. So let's open up this SSH guy. Z Spider Labs Sheepl output. So that's what we just created. Let's hide that window for a minute. So you can see putty connection. Again, I won't make you wait 20 seconds. This is the thing with like just doing one task over a minute. You can't go less than a minute at the moment. Didn't seem to be any point. So that's why you have to sort of bake it in yourself. So the issue is this here. The bug that he submitted was that he was then finding that O was being appended, prepended to the username on every run, which I couldn't replicate until I left it looping. So let's let it go. I'll show you the screen as well, so you can see that. So assuming that server's there, 3 seconds, it should then start putty. Obviously putty has to be installed. You can see it's done that O bit to accept that window that's coming up. Logs in. Couple of seconds, password, and then at this point, so now we can drive Linux from Windows. Good for keylogging, but good to start like generating traffic in from Windows to Linux and different operating systems. LS, and then it should run uname, and then it should come out again. And then I'll let it loop so that we can see the bug in real time. Come on, quicker. Okay, so that's the first time round. Should be fairly quick to go again. Yeah. Oh, it hasn't done it the second time. So it's a bit of a race condition then, I think, because that Alt-O is to accept a pop-up. And I've also got some more that I need to think about, is because when you make a putty connection for the first time, it comes up and it prompts about, hey, do you want to accept the SSH key for this? So we need to deal with that window as well. So I'll let this loop one more time just to see whether it does it third time lucky. And if not, I think this is a good point to show you the auto-info file so that we can reference this putty task and you can see how you pick up these bits and pieces of windows that you need to watch for and interact with and respond to. So let's see if it does it a third time. Doesn't look like it. It should be there by now. No? Show off. So yeah, it's a weird bug. Because I'm typing, you have to forcibly stop it. I have managed to fix it anyway this morning, which is basically that Alt-O doesn't need to be there, really. So I'll just swap that out. So in that AutoIt bundle, or if you've installed AutoIt, you get this program called AutoIt Window Info. And this is brilliant in like learning how to build your own modules and extending stuff. So if we take the putty example, if we start putty up, what is it that it's actually hooking on? So in this SSH guy, here, you can see, look, there's a WinWait active class putty box, and it's got this 10 here, which is 10 seconds. If that isn't defined, it means that it will wait forever until that window becomes active. Now, you might want that to happen, but it literally will wait forever. So I had a bug where I introduced that I'd misspelt remote desktop in the module. I fat-fingered it, and I got rid of the fact that it would wait for 10 seconds and then bomb out. It would just wait, and it waited for this thing for like days. And I was like, what is that doing? And then I realized that I'd got it wrong. So yeah, so you know, it literally is that explicit. So how do we find this sort of stuff? So this is basically a drag and drop. So if you click this here, and now you're interfacing with anything that's within your Windows GUI, which is really cool. So you can click that there, you can click the overall configuration box, and you can see that that's where we get the title, but also the class as well. So that's what I'm signaturing, that's what I'm hooking on, is the class, because it might be at some point that putty configuration title could change. But the class title of the Windows box won't change because it's part of how it's built. So that's pretty cool. That's basically how I start. When I'm thinking, well, what do I want to start with? How do I normally start the program? You'll have seen that I generally use Windows R and type it as a run command, but you don't have to do that. You can do other things to start it. But then once that program started, how do I hook it? And that's what I'm using. I'm using the class title to say, send keep active. These two things are pretty much the glue of that Windows management, that they're going to wait for that to appear. And once it appears, it's going to specify that that is the active window, and then it will send commands through that. But what's cool is that all of these buttons also have classes as well, controls. You can see that there has a class of button, and you can go through. You can even signature on visible text or attributes. It gets quite specific in what you want to click, and you can send a click command for that. So that's quite cool. But this Alt Open is where the problem is, down here, because I'm sending that as a keystroke to make sure that it opens it automatically. But I think, if I'm wrong, if you just hit enter, it does it anyway. So I don't need to account for that sending of Alt O. I don't need to account for that keystroke because enter will do it for me. Which might be better, to be honest. So I think that's the solution to that problem, but at least you can see that that's a live bug anyway. So I think at that point, let's make some Sheepl that actually move around a little bit, connect to remote desktop servers, SSH to things, you know, and then we can spend some time looking at how you can potentially build your own modules, how the JSON profile works, and how you can do cool things like drive Kali as well. Because somebody said to me, well, how do I actually make it attack? So, well, you could drive Kali over SSH. That's one solution, you know, because Metasploit has RC files and stuff. That would work. But with the advent of this world where you can run Linux with inside Windows containers, which are essentially Windows GUI controls, I've now got solutions where you can install Kali on Windows and then drive Kali to attack other things. So that might be like you want to spray for MS-1710 and you want to literally trigger that across a network segment at some point in a couple of days from what constitutes a malicious box. So at that point, we're not automating attack, but we are thinking of ways that we can create even more realistic attack traffic to signature off. So I think let's get some SSH going around and see if you can do that, and then I'll show you some more funky stuff. Scream if you want any help. I can give the IP addresses of things that you can SSH to directly from where you are now. There's a couple of Kali boxes in the public as well. So there's one on 70, there's one on 69, they're Tor. So if you wanted to SSH to those, then you could use those to then start SSHing through. Bear in mind that it needs Windows. So in terms of using Autoit, you start with a Windows box. There is no concept of running a Sheepl on Linux directly because it uses Windows APIs under the hood. So that's never going to happen. But this came about because somebody was like, well, I want to be able to control Linux and run things around. And I went, well, maybe SSH would be a good solution. So at this point, anything that you can do through SSH, pivoting, port forwarding, all that sort of stuff that you know how to do yourselves, you can make a Sheepl do because you can type it. And these ones here, Fortis Network SSH2, Fortis Network SSH1, so 68 and 67. And there's also a dev one, which is in a different network range, which should be routable from where you are. So you should be able to get to that one. Or we could set it up so that you can pivot through them. So you could SSH to one and then send SSH commands through to another one and pivot through that way.
Trying to see the list, and I did the subtask list.
Oh, and it bombs out.
So I don't know if it's like normal or if it's my computer.
No, that's a bug. That's a good bug. So what was that one for that you were using? The run command? Yeah, so the run command is literally what you think it is rather than using run to then spawn a process, it's just whatever you type in that run field, it will send, which is good for the responder stuff where you can type incorrect UNCs and things to respond to hashes, etc. Oh, what am I doing? So what did you do at this point? Subtask list? Boom. Thanks very much. Bug. Live on camera as well. Perfect. So. I think that actually comes from higher up. So if you look at like the output for run command here, you don't see that command in the list. So subtask underscore list is not defined as a command. So you've got the new and CMD and assigned and complete, but you don't see that command, and that's because of the inheritance on this one, like base CMD. So if we go into where is it? Utils, I think. Utils? Where is it? Base CMD. So because it's inheriting, then that subtask supported comes through from here as a command option. So I'll probably check to see, yeah, look, it's just passing. So I'm not actually doing anything with it. So it's expecting something that it's not getting, and then it's bombing. So that's cool. Thank you. That might, at least I can fix it there, and then it will fix for everything, basically, which is kind of like before, if I found a bug, because I'd sort of replicated this cookie cutter approach, I'd have to go and fix it in like 300 different places, and it was really annoying, and I was like, this is just not going to work. So yeah, that's cool, and I'll submit it as an issue, or you can submit it as an issue, it's up to you, but I'll submit it and then get it fixed. Where it does work, actually, if you're interested, let's discard that, and I'll show you how it works with RDP, which is why you have the subtasks. So remote desktop is by far the most complicated. And you have the same sorts of things, so you define credentials and you define what's going on. I'll just do anything. And that's where it becomes applicable. So inside remote desktop, you can say, cool, I've just done the initial credentials. So there's nothing there, but you've got show credentials. So I've done the initial, this is how you make a remote desktop connection to something. But then if you call subtasks, subtask even, you basically get a replica of everything that you've had before. And you can see remote desktop is there as an option. So this idea of you create a module and then it should not only be available locally, you should be able to create it somewhere else works. And because of that, you can actually chain remote desktop. So you can go RDP to this, then RDP to that, and RDP to that. It gets a bit crazy, like finding out which keyboard you're eventually on as to what gets sent. But that is possible. I'll probably have to limit the levels of that, but that's basically how you do it. So I would then say subtask command shell. And now you can see, I mean, this is all fresh, right? So it might need people's opinions as to how well it works. But essentially, we're creating a subtask inside it, which is exactly the same thing. It's calling itself again. So I'm now making a new one. And I would just use the module in exactly the same way. Yeah. And then once I'm finished, I'm back again. And now you can see that inside there, it's completed. So if I actually complete this one for you, you'll see how it works. Complete. Back. Finished. All right, bug. So you can see, like, subtasking and stuff, it gets pretty complicated to understand where you are. But there's the bug one. So how this is different now is that you don't see that command shell that I've just assigned. You don't see it as a global task anymore. What you do see is it goes through the loop, and the only thing that it's calling at the moment is RDP. But inside RDP, what it's done is it's then written out the subtask stuff for all the command shell interaction. So I'm explaining it now, and even now I'm like, what? It just kind of jumps around. But essentially that's what we're doing. Inside there, we are calling the same function that we've written here with ipconfig. It just gets called in the context of remote desktop, if that makes sense. Once you write them more and more, you'll see. But I guess there's going to be a point where subtasks aren't applicable in remote desktop, and I'll probably have to put in some flags to go, you can't really use this anywhere else. But for now, it's a pretty bulletproof solution. But to wrap up, so this is kind of where I'm going with it. As you can see, like, I think the structure is there for this version, and it's fairly extendable, and the typing ability, as I said before, I think that's really important. Adding in the backspacing. And I was like, well, how do I define the formatting for things like Word and stuff? So I'm basically going to steal markup, markdown even, call it all hats, each sheet thing going. But essentially you can specify like the double hash thing so that it implies that when that Sheepl is typing in Word, this thing it types. So it will do that version of making it into a header function, etc. This is a bit more tasks, as I said before, and then really looking at how I can use the IE stuff to extend the web interactivity. It seems to be very, very powerful in the snippets file that I've shared. There's loads of examples of how you can specify your own headers and post data back and forward. So I think there's a lot of opportunities there to make them fully interactive in terms of application tag and testing. So thanks so much for coming and spending time with me this morning and listening to me harp on about Sheepl for the last couple of hours. I appreciate it's been a bit full on, but I've really enjoyed getting into the nuts and bolts project that I've been basically harping on to him about quite a lot. So I hope that you can see that there's some use there, and I would be like, please send pull requests or contact with kids for ideas about how you think that it can go next. So I kind of feel from the project owner's perspective that I've got it to the point where I know how I would use it, but how I can now extend it is somebody going, this would be really useful to do this, what do you thought about that, and I kind of want that collaboration.